We're Optipulse. What is 6G? I'm going to start out with that question. It's a wireless technology that's faster than 5G, uses less energy, costs less, and is easier to deploy. Optipulse is announcing world's first 6G emitters for sale to product developers. We're seeking $8 million. Next. So, hi, I'm John Joseph. I'm the CEO, founder, and I lead an elite team of photonics professionals. We all worked together many years ago at the national labs, and we're known for optimizing the first laser transceivers that enabled fiber optic communications. Next. What we've discovered is a new type of photonic source that has enough power to give us wireless connections at distance. What this will really mean in the future is a better communications model. We can do 25 gigabit per second backhaul, low energy use, low cost, fast deployment, and this will all bring about a digital equality. Next, please. What we have is 8 patents issued on a new type of photonics light source. And as you can see on the picture with the finger, that has a tiny chip on it. That chip has 37 lasers on it, and there's the microscope image of it next to it. It has lasers on one side and micro optics on the back. The combination yields a very unusual type of light source. Basically, as you see here in the left part of the screen, if you image on the surface of the chip, you can see, in this case, it's 19 lasers. But if you image back through the chip in the focal plane, you will see back here at about a millimeter and a half, you have a very uniform power source. And so this is the power intensity, which is like a top hat profile. And that means we can project that into the far field at gigabits per second. These chips have been tested at 25 gigabits per second with simple on-off keying. What can you do with these things? Well, since the micro optics allow us to sum the beams together, we can also move them in the X and Y and allow us to put multiple chips on a single beam. Now that allows us to multiplex and wavelength and pulse amplitude multiplexing, pushing speeds, bandwidths up to hundreds of gigabits per second. Also, if you can array these and you move those micro optics around, you can actually use non-mechanical beam steering, which enables, like, imagine a projector in the far field and a drone coming through this, and you're able to sense and communicate with a moving object. Next, please. So what does this allow you to do? There's an amazing amount of use cases here. Just to give you some examples, backhaul, front haul for 5G and of course 6G, infrastructure, different speeds, but let's just take the automobile vehicle to vehicle communications market is projected to be 139 billion in 2017. Next, please. So we are delivering the modules for the 6G emitters, detectors, evaluation boards, and evaluation links in Q4 of this year. We'll be doing mesh networks in 2022. Next, please. What can you do with this chip? Well, you put it in our prototype 3, you put it in a system. We've had 10 gigabit per second building-to-building communications, and that we have taken that was a mechanical system. Now we have a digital system, which is self-aligning, and we'll be testing this in September of this year and in our alpha product, and have the beta out by Q1 next year, which we will be selling to developers for their systems. Next, please. What problems does this solve? Well, if you can imagine a fiber optic installer that has to come to a river, what do? We've heard from our customers. We were in the NSF I-Core training and had to talk with 100 customers. One of them told us $360,000 in 3 months to get across a one foot river. And that is because you can't go across bridges. The Army Corps of Engineers doesn't allow that to happen, any kind of structural changes. There's all kinds of use cases going across highways, bridges, and cities, train tracks, in a mesh network with redundant links. But the very interesting thing is what this will really lead to is a better way to connect rural cities next, which enables space links that can be transported over to a rural community way out of the way that with a fiber optic speed next.
30-second warning.
Okay, so thank you. Lots of traction here. Can't go into all of it, but I'll sum it up. With our Department of Defense contract, we got an overachievement status in phase 1, and we are in phase 2 on schedule and on budget next. So we're seeking $8 million. Here's the details on that. And basically it's a 1.5 years of chip development, forecasting, deliveries, and engineering applications, sales and marketing, and IP development next. That will give us 2 years of basically in 2 years we'll be cash positive, and we are leading the way to 6G development. We're looking for investors that are not afraid to change a lot of problems that we have today in communications. Thank you.
Thank you, John. So John, I know you've had quite a lot of traction so far within the government, and you've seen a lot of traction also through the showcase, both in government and also in corporations. So we're opening up the floor at this point. We ran through it real quickly. I'm just going to recall everybody the panelists for this session. We have Ryan Hatcher from Lockheed, Jeff Everett from Moog, Alex Ferber from Green Egg Ventures, Destry Grogan from Army Futures Command, Sodi Yoshi from Mitsubishi Heavy Industries, Alan Yu from Space Capital, Tim Crane from Army Futures Command, Whitney Tallarico from Naval X, Charles Quofer from Siemens Digital Industry Software, Jacob Hahn from Deloitte Consulting, Jen Noborikawa from City of New York, and Joshua Davis-Court from the United States Space Force. So open up the panel, as I said before, additional panelists, if you already on for your later session, feel free to jump in if you have something to say to John and Optipulse.
Anybody got any questions?
Can I just speak up?
Yeah, go ahead, Ryan.
Yeah, sorry. Hey, great presentation. Thank you for that. I'm curious about the impact in your link budget with rain or smoke or fog or dust. Do you have any estimates on that or any data?
Yeah, we've what we've do on the chip is we expand that beam out through the into the through the micro optics into the macro optic, and that beam expansion allows us to get through a lot of the weather issues like snow or rain, where small objects, of course, if you're sending data from one link to another, you only have a few microseconds for the data to get across. So typically there's plenty of light that you can collect on the other side that gives you the data you need. Now, of course, it's all based on power, just like RF. It's based on power. Is how much power are you able to get? Well, that's what's so cool about our technology is that 105 VCSELs is just as fast as 1 VCSEL on the same chip. And that allows us to get amazing amounts of power, turn the power up when it's necessary. There is going to be an atmospheric point at which you can't go any farther, but we definitely have the way to beam steer and get higher power. Thank you. Thanks, Ryan.
Can I ask a quick question, if it's okay with everybody?
Actually,
John, great presentation. Actually, I have a particular interest in your field. That's why I wanted to kind of speak up. I know 6G has a lot of great potential, as we all know, but there's always this issue with the security, right? The security and privacy issues, right?
Yes.
Especially like this 6G is basically it's greatly be used in connected robotics or autonomous systems, right? Typically rely on like AI and VLC technologies. So can you comment on that? How are you going to overcome? What's the plan for that? Or please.
Sure.
And also one more question here. Have you attended the first, I believe, first 6G conference was in Finland. Have you attended that 2019?
No, we
right
did
before?
not.
Oh, did not. Okay.
No, but thank you for that question. Very good question. Of course, 5G is based on a cell technology, which is high frequency RF. But the problem with 5G basically is that once you get to those kinds of frequencies, it's line of sight. Well, so is light, but we can do things that the RF can't do, like go through a window at with their high frequencies that allow a gigabit per second, or a couple of gigabits per second. We can put a light beam through a window at 25 gigabits per second. So what we're trying to do is show a new model in 6G that allows like a 4G on steroids, which gives you excellent cell phone connectivity and very high bandwidth. The real issue with our bandwidth is basically the backhaul that supplies the RR units for cell phone service. And so we're able to get a really high backhaul in a mesh network with a type of smart pole that we can go into later. But thank you for that question. And the security part, optics, of course, we're at the NIR or near infrared wavelengths, so much more secure than the radio wavelengths that is 5G right now. Thank you.
Great. Maybe we can perhaps chat afterwards, please. Thank you. I'll put my email in the chat room. Thank you.
John, two things. One, thank you for working on a tech that's actually not RF, because I've been hearing a lot of people concerned about 5G, genetics and health and safety issues and concerns and things like that. So I think you might have solved that problem. And that's first question. Second question, have you worked with Talos in France? They're have 80,000 employees in the security space, so they may be able to help you with anything you need in terms of securing or government or military grade security.
Well, thank you very much. Yes, I do know Talos, and I did meet with them early on when we were forming our company, but we didn't have systems ready. We just had theory. So we've done quite a bit since then. We've been open for 6 years now. And we'd certainly like to meet with you and talk about that, because they actually have the systems that for driving high current drivers that we really could use in our modules for space and telecommunications. Thank you very much for that question.
Reach out to me when you're done, because I have high level contacts at Talos who are doing the whole digital. They're changing everything from hardware to the cloud. So the whole data transformation architect I'm working with.
Thank you very much, David. I will certainly do that.
Sure.
Background, David's from Proto Ventures. He's mentioned contact with Talos, but David's from Proto Ventures.